Hello, everyone. Good evening, good afternoon, good morning, good night, wherever you're from. Thank you so much for joining in. I'm very excited to have you guys here, and I'm very excited to deal with graphical interpretation and table analysis questions today. Before we begin, a little bit of brief about me. I'm working as a subject matter expert at GMAT, but 3 months ago, I was exactly where you guys were, struggling with DI, struggling with figuring out GMAT. When I first started, my score was 395. I think it was like a 7 or 10 percentile in DI. I don't remember. It was just so low that I just closed my laptop that, okay, DI is very, very difficult. But after that, I worked on verbal, quant, and then after that, I perfectly worked on DI. And I ended up getting a 97 percentile on DI in my final GMAT, on my final GMAT, if I remember correctly, with a 715. And the reason I'm sharing this with you guys is to show that a lot of times we get discouraged when our initial score is not that good, when we start out, when things are not going that well. And I just want to show you that it's not something that you're born with. DI skills are something that are absolutely learnable, that you can actually learn and you can implement, and you can get a fabulous score. So yes, with that, let's begin. Yes, one very, very important disclaimer. If you have attended any of my earlier sessions, you would know this. And I'm very particular about this. I want you guys to participate. Right now, you guys are going to give me like an hour and a half of your time, maybe even longer than that. And I want to make sure that this session is extremely productive for you, that you get value out of it, and you are able to increase your accuracy, you're able to increase your score out of this. And I promise you that it'll happen, but just one condition: I need you guys to participate. Even if you're someone who's watching this video later on, when I'm asking questions, take a pause, think about it, answer, and then play the video. And if you're live with me, please put all the answers in the comments. And this is not a Netflix show, okay? We are learning together, we're going to be discovering things together. And now we're going to start with solving graphical interpretation and table analysis questions, which are actually such that if you get the hang of it, they are one of the easiest ones technically on DI, and they are the ones that you can get a lot of scores out of. So yes, before we start, I want to know you guys, where are you guys coming from? I will meanwhile share my screen. Mm. And yeah, those who are going to participate the most are going to get the most value out of it. Okay, is my screen visible to all of you? Okay. All right. You know what? Let's just get started. Pune, Bangalore. Oh, wonderful. I'm also from Bangalore, South Africa. Fantastic. Austria, great. We have people from all over the world. Awesome. Fantastic. Okay. So, with that, guys, I want you to solve this question. Let's go. I'm gonna wait until a couple of you see that they have already solved it. Put that in the comments, and then we're gonna go with the explanation. So let's go. I'm gonna give you like a minute and a half, 2 minutes, and time starts now. As soon as you complete, you can start putting your answers on the chat box. Okay, guys, final 30 seconds and then I'm going to go for the explanation. So please, it doesn't matter if your answer is correct, incorrect, just put it in the chat box. It's actually great if your answer is incorrect because that's how you will know where your thinking was wrong and you'll get to learn. You're not going to be judged on the basis of this. Okay, C and B. Okay. Anyone else? B and B. Okay. C and A. One more person is saying C and A. Okay. Any more answers or should I start? All right, I'm going to just get started with the explanation. Thank you guys, whoever participated. Thank you so much for participating. We have C and B. Interesting. So, we don't have a unanimous set of answers. So, this question is actually a 705 plus question. It is a very difficult question, confuses a lot of students. I, in fact, remember doing this question months ago. So, it is definitely a complex question. And the way that we are going to deal with this question is that we are going to look at the data set. We are going to use the approach called owning the data set, where before we even look at what is asked, we completely internalize the data set, we draw inferences, and we see what the question is actually asking, right? And this is one thing that I want you to do now in this question and in the questions that are going to come up. For every single question, before even solving, think about it. What are the inferences that I can draw? What are the inferences that I can draw from this particular data set? Okay, I'm going to show you what this means. So let's get started. Okay, let me get my pen. All right. So I usually like to read the text first, and while I'm reading the text, I like to look at the entire diagram flowchart. Okay. So let us look at what's happening here. A certain city's bus system includes several stops within a university's campus. Okay. So there's a particular bus system, it has multiple stops. The city has devised a new plan to decrease the amount of time bus drivers devote to receiving payments at the busy university stops. Okay, so we're talking about some sort of a new plan. All right. Under the new plan, outlined in the diagram. Okay, so here is where we're looking at the diagram. Passengers would pay upon entry, pay upon exit, or ride free. Okay, so what are the outcomes? So there are three outcomes. Aditi, just give me a minute. Right after we are done with this, I'm going to address all the doubts. Okay. All right. So under the new plan, so have three particular outcomes. So there's only three things that can happen, right? So we are going to start from the end. Either they will pay on entry, they will pay on exit, or they will ride free. Okay, these are the three outcomes that can be there. Now, what is it depending on? So these are the output metrics. So what are the input metrics here? What is it depending on? Depending on the time of day, boarding location, departure location, and whether they have a valid student ID card or not. So let us just look at here what's happening. Look in the flowchart what's happening depending on the time of day. Yeah, it said that. Okay, depending based on whether they're boarding at 6 a.m, 6 p.m, you're either like paying on entry or not. Okay, they're on their boarding and departure location. Okay, are they boarding at a university stop? Are they departing there? And whether or not they're presenting a valid student identity card. Okay, so this is all of the input that is happening, and based on the particular input there are three output things that can happen. Now, before we even look at this, before we even look at what are the potential outputs that can happen, let us have a look at, sorry, yeah, let us have a look at the different flows here. Okay, and I really want you to pay attention to this particular methodology. Okay, for getting the first outcome, pay on entry, there are two flows. Flow one, which is that they did not board between 6 a.m. to 6 p.m., and flow two, which is that they did not board at a university stop. So this has how many flows? Two flows. Okay. Now, secondly, if you're talking about pay on exit, is there how many flows are there? There's just one flow. There's just one endpoint called pay on exit. No of something is pay on exit. So that is one flow. Here, if we look at ride free, okay, again, here also we have two flows. Either they're exiting at a university stop or they're presenting a valid student ID. So there are two flows. Is it clear? what we did, we haven't even looked at the question yet. And don't worry about time right now. We haven't even looked at the question, but just based on the data set, we have inferred that to get the first outcome of pay on entry, there are two ways we can do that, right? We can either not board between 6 a.m. to 6 p.m., or we can not board at a university stop. Awesome. For the first one, there's only one floor that you can not exit at a university stop. And for the third one, there is two floors that you can either exit at a university stop or present a valid ID. Perfect. Now let's look at the question. What the question is saying. According to the diagram, under the new plan, if a bus passenger, this is one of the three outcomes, right? If the bus passenger, has either right tree, pay on exit, pay on entry, then the passenger must not have done one, two, three. Now, think about it. When it says must not have, and the word must is so important. And a lot of times, questions are asked on must not, or some like things like that. And it's really important to know what this means and what we can infer out of this. So out of this, I want you guys to participate. When it says must not have, what do you infer out of this? What do you mean when it says must not have? What does it look like in your head? Think about it. Even if you're like, you're a viewer, you're watching it later on, at this point of time, pause and think about it. When it says must not have, what does it mean to you? Let me just give an example. If let us say there is an outcome X, there is A and B, two things that are causing outcome X. Can we say that A must have caused X? Can we say that? It's not possible to get to that node. Uh, Interesting. I mean, it is possible to get to that node, but it's not the only way that's possible to get to that node. I think that's what you are trying to infer. Might not. Exactly. Yes. Good of the thing. Might not have, right? So if two nodes, if A and B, there are two ways to reach X. Can we say with 100% certainty that A must have happened? No, because B could have happened, right? Can we say with 100% certainty that B, B caused X, B must have happened? Correct. It's a mandatory condition. We can't say that. So what do we get out of this? If there are two ways to get to one particular path, we cannot say with certainty that either A happened or B happened. Is that clear? Is that clear to everybody? So if now that this concept is clear, what does this mean for our question? When this says must not have, what is the inference that we are drawing out of it? Think about it. What is the inference that we are drawing out of it? Answer is CC. We'll get to that. We can draw the first thing, right? We can draw the inference that the only way that the must condition is fulfilled is if it has one flow, if it has one node. We cannot say that it is pay on entry, because if one would not have happened, two would have happened. Two would not have happened, one would have happened. Similarly here, because it has two flows, we cannot say that something must have happened. Does it make sense? Am I clear? And do you realize this is how we are drawing inferences? And this is something which is very a lot of times people get stuck in these questions that, oh, you know what, this can also be the answer, that can also be the answer. How do we figure out which one is the answer? How do we figure out, how do we narrow down the choices? And this is how you narrow down the choices. When it says must, it is compulsory, it is 100% necessary that the outcome must have been pay on exit. Yeah, absolutely perfect. It's one flow. So we know for a fact that the answer here is B, pay on exit. Perfect. Now we just have to figure out how we got there. Perfect. So now that we know that we are supposed to figure out pay on exit. Okay, so we know that the passenger must not have. So it's a very clear thing that, okay, if it says no, so he must not have exited at a university stop. But let's look at the options. Is the option there here? No, the option isn't there. Okay, So let us go up. It says boarded at a university stop, but it is yes. It is yes to boarded at a university stop. And a lot of people did answer, like, did get B right, but said that boarded, but got C as the option. But must not have means, what does must not have means? Uh, yeah, for must not, this has to be a no, right? If A must not have happened, then X happens. If A must have happened and then Y happens, so then this is not a must not have. What is it saying? It said must not have. So the here it has to be a no. Does it make sense? This has to be a no. It cannot be a yes. So how can it be boarded at a university stop? Because boarded at a university stop directly causes pay on exit. So boarded at a university stop must have happened for pay on exit, right? So what do we go? So we go one step above. We have a no here. Presented a valid student ID? No. So this is our answer. It is B and B. So do you realize how we did this? Basically the principles we used here are principles that can be applied anywhere. So whenever you are having a kind of a flow diagram or anything of that sort, first of all, you need to figure out that, okay, how many flows are there and what leads to that flow? And especially, is it a yes or a no? Whoever got this wrong, is it clear how we are supposed to approach this? Even those who got it right, is it clear that this is something which is a universal thing? We can apply this across questions, so that when we are having, like, something which looks like a really complicated kind of a flow thing, all we need to do is we need to look at the outcomes, we need to look at the number of flows causing that outcomes, and we need to draw inferences from that data, and based on that, based on either a yes or a no, excuse me, we can come up with the answer. Awesome. Great. So I hope that this was clear to you. Great. Now let us look at. So Aditi had asked a question. I think somebody had asked a question that, how do we. Okay. Just give me 1 second. Yeah, Aditi had asked that question, that how do we ensure that, if you are reading the data set properly, so then that is taking up a lot of time. So how do we ensure that, like, we solve it within time? So if we look at it, I mean, I spent a lot of time explaining it, but if we look at it, like, when we are reading the text and relating to the chart, that's like 35 seconds. Chart is 10 seconds. Reading the question, determining the approach is 25 seconds. After that, execution is only 10 seconds, right? If you are not internalizing the data set, what you're going to do is you're going to be very confused, and you're going to keep going back to it. You're going to keep like, okay, what exactly happened? What is the flow here? You're going to be very confused. Yeah, so you're gonna keep thinking that, okay, which one is it? Especially because there are three and three here. So there are two things that you need to figure out. First, which of the outcomes is there, and then which of the input led to that outcome. So that is going to lead to, so much confusion to you guys. Sorry, that's going to lead to so much confusion for you guys. But because you have done this, because you looked at the data set, you drew the inference from that data, you knew that the answer could only be B. So you only had to look at one flow. You did not have to look at all three flows. So essentially, because you drew inferences, you ended up saving so much time. And that is essentially what the no. So you do not get points. That is the worst thing about table analysis and like graph, that no matter everything you get right, but if you don't get all of them right, you do not get a point. So yeah, so because of all of this, not only could you solve it in less than 1.25 minutes, but you could also get it correct. And this question has like 31% people getting it correct. But now that you look at it, it is actually quite easy, right? You're just tracing the logic back, right? So that is the magic of this approach. Okay, now I have a question here. Jaideep says, since for a passenger to pay on exit, he could only do that if he not does not present a university student ID. Perfect, exactly, Jaideep. There's only one way. That is the thing, right? If we look at the rest of the flows, there are two ways to pay on entry. Either they could not board a university stop, or they could not board between 6 a.m. to 6 p.m. So the must condition is not fulfilled. But because this is only one flow, this is the only place where the must condition is being fulfilled. Awesome. Now let us go and let us do the next question. And now I want you guys to practice this approach. Own the data set, front load your time in understanding the actual data, and then work on the answer and answer choices. Okay? And we need to get this correct. All right, so this is the second question. You're going to get 2 minutes and use this approach. And the most important thing, figure out what inferences can you draw out of it. Okay? I'll just clear this so you guys have no distractions. And I will also shush. Start. So Jaideep, once you follow this approach and once you kind of figure it out, DI is going to be very fun to you. By the end of my prep, DI was like the most fun thing for me. But okay, please we'll solve this question now. As soon as you're done with it, put the answer in the chat box. A little bit quicker, guys. Last 45 seconds. Okay, thank you, Shubham. Anybody else? Okay, so we have again a mixed bag of results. People saying CB, BC, BB, CC. I have four answers, all four of them different. Okay, B, and I have five answers, all five of them different. Okay, got it. All right, now let us look at the actual, let us solve this exactly like what is happening. BB or you can't say or, you have to give like one answer. But thank you for participating. Okay, like now let us look at this data set. What is this data set saying? So this says that at the end of each year, the Harkar Corporation assigns a rating to each member of its sales staff. Okay. So basically, like now, let's say there are 10 staff members. Okay. So what I'm doing right now is as I am reading the data set, I'm visualizing the data set. Now, what does visualization mean? There's multiple ways that you can define visualization, but essentially, after every sentence or after every phrase or after everything which is like slightly complicated, I'm simplifying it for myself. So like I'm not just passively reading. after I complete a little bit, I'm actively kind of trying to draw inferences that what does it mean? Okay, and that's what I want you to do as well. Okay, so at the end of each year, the Hardcore Corporation is assigning a rating to each member of its sales staff. Okay, so let's say it has 5 people, it's rating assign, okay, you are 4, you are 3, you are 2, you are 1, blah blah blah. So okay, it's assigning ratings. So the sales ratings are based on the mean and the standard deviation of the individual sales totals for the year. Okay, so what does it mean? Like, basically there's an entire mean and there is a standard deviation. And on the basis of these two things, there is some kind of rating. Okay, so basically this is a mechanism of the numbers. Okay, and there's a formula. It can be computed by applying the following formula and then routing the result to the nearest integer. And this is the formula. Now, we don't need to go very much into depth about, okay, what exactly the formula is meaning and all of that. But what we can infer out of this is that this mean and the standard deviation, that is something which is there like for the entire company. Like for example, the entire company's mean is 30, and if this particular employee is doing 10, so his rating is going to be on basis of this formula, versus if it is 30 and this guy's rating is, let's say, sorry, if this guy's sales are, let's say, 40, it's going to be done, he's going to get a higher rating based on this formula. So if I had to explain this super complicated piece to somebody who is like, in studying in 8th grade, what would I do? I would simply say that basically based on your comparative performance to like with the rest of the company, you are getting a rating. Right. So it is a comparative performance. How many of you were able to draw this inference? Were you able to draw this inference that what exactly are you doing the ratings on? Like, what is the basis of these ratings? We don't need to go into the formula, but we need to go through what is the basis of this. How many of you were able to draw this? Say yes, no in the chat. Yes, no, maybe, anything. Okay. Now let us look at let's look at what it's saying next. So it is saying that sales staff are considered to promotion if the rating is 3. Okay. So if we look at the chart here, now we'll look at the chart. Partially, yes. Okay, good. So now if we look at the chart here, so what is the x-axis? It is the individual sales rating, which, what are they? They are comparative. So these individual sales rating, okay, they go, oh my God, someone gets a minus rating also, -3 to 3. Okay, so this is like all of the different individual sales rating that can happen. And it says that they're considered for promotion if their rating is 3. So this tiny little piece of people here, they're considered for promotion. And this graph is showing ratings for the entire sales staff for 2009, 10, 11. Okay, so 2009 is blue, 2010 is gray, 2011 is orange. Okay, so we are seeing that like for and what is there on the y-axis? It is a number with rating. Okay, so let us say, what does that mean? So before we even go into the question stem, let us figure out what this bar is telling us. And this is the technique which I like to use a lot, wherein I look at like, let us like one data point or one cluster of data point, and I try to tell myself or teach myself in my head what this means. So let us look at like the data point of -1. So what does this mean? That the blue one, that is like somewhere near 60. So this means that there are 60 people in 2009 who got the rating of -1. Okay. All right. And if we look at the gray one, so okay, there's 80 people in 2010 who got the rating of -1. This is the second inference that we are going to draw out of this. How many of you were able to do this? Put it in the chat. Even if you're not putting it, think about it. Think, were you able to draw this or not? And if so, why? If you were able to draw, why were you able to draw? If you were not able to draw, why were you not able to draw? And this one technique, right? This is something that is going to be so useful for you in like, all kinds of graphical interpretation questions. Amazing. Very glad to know that you guys were able to draw these inferences. Awesome. All right, now that we know this, okay, now that we have understood what this is saying, now let us go into the question. So this says that the graph either supports, refutes, or neither supports nor refutes the claim that the sales staff had fewest members in 2010. Okay, all right. So if we look at 2010, so what are we going to look at? We are going to look at the gray areas. and it says fewest members. So before we even go here, can we infer how many members are there from this chart? Can we do that? Yes or no? Yes, Priyanka, correct. Yes, Aditi. Okay, wording is weird number with rating. Yes, makes sense. Yeah, and you know, like certain times the wording is going to be a little bit peculiar, but the more and more and more you'll do questions, the more you'll get out of it. Yeah. So can you ascertain, however it's pronounced, can you figure out from this chart how many people are there? You know, can we figure out the number of people from this chart? Yes, no, maybe, I don't know. Yes, okay, great. So we can figure it out. Okay. And then, okay, so now let us look at this. The claim says that the sales staff are the fewest members in 2010. So we are going to look at the gray areas. So if we look over here, gray here it's 5, it's the highest. This again, this is 20, it's the highest. It's the highest. It's almost like second highest, but quite close. Here also it is the highest. Here also it is the highest. Here also it is the highest. So it's absolutely, it's not the fewest members, right? If any, it is the most members. We cannot say that the sales staff are fewest members in 2010. Isn't this obvious? If we look at the gray, we don't even need to calculate at this point of time. And that is the magic of drawing visual inferences. We are not sitting and we are not calculating what is happening, but we are saying comparatively because they said fewest. That means that we can compare, right? And comparatively, gray is at the highest. So it is unlikely, it's not unlikely, it's not possible that gray is going to have the lowest members. So this graph refutes that. So the answer to this is B. Now, let us look at how many people got B. Let me see. B, 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 B. Okay, a lot of you got B, barring 2 people, but fantastic. All right, now the second one. The graph dashed the claim that as a group, the staff's total sales were highest in 2011. Is this chart giving us information about total sales? Yes or no? And now I'm going to wait until you guys answer yes or no. If you are watching it later, then pause and think in your head yes or no. Is this graph giving us information about total sales? Aditi says no. Okay, what do other people say? Think about it. Look at this graph. Take like 20 seconds if you need to. Is this graph giving us information about total sales? On the x-axis, we have the individual sales rating. On the y-axis, we have the number of people with that rating. Not directly. Okay, Jaideep. So you think that it is indirectly giving us information about total sales volume? Comparative, as you mentioned, when I was solving, I assume no. Okay, good. Individual sales. If we all have individual sales, do we get total sales? All right. If we look at it, it's not individual sales, it is individual sales ratings. And how are the ratings calculated? They're calculated on a comparative basis with the other people who are, having that rating. If we sum individual sales, we might get total sales. Okay. Interesting to see a lot of people's viewpoints here. It's going to be fun. All right. Let me give you an example. So let us say the median sales are in 2009. Okay. They were 10 million. So there are, let us say, people who have 2 million, and there are people who say have 20 million. So this person is going to have like a very negative rating, like -3. This person is going to have +3. And it doesn't matter how many people were involved, right? But let us say in 2012, we have 50 million. There are some people who made 49 million. There are some people who made 51 million. Now, what does this say? Number with rating. This 10 million could have been made by 100 people, and this 50 million could have been made by one very, very intelligent person. Can we say that? Because we don't know, right? How many people made that? Like what? Like we just know how many people made those sales. We don't know how many sales were made. So this access is not telling us anything. Just because a company has more employees, it does not mean it is going to have more sales. Am I making sense to you guys? Does it make sense? Y axis doesn't mean anything. I can have 100 people making $10 million dollars and one person making $50 million. Dollars. So this axis is not telling me anything about sales. Is it clear? That's not telling me anything about sales. Now let us look at this individual sales rating. Let us look at 0, 3, minus 3. What does it represent? 0, 3, minus 3. Awesome. Great. Glad to know that you guys are diagnosing what exactly happened. That's amazing. That's a very, very good skill to have. What does 0, 3, minus 3 say? That says how far you are from the median. 2, 10, 20. Just because you are far, it doesn't mean that sales are higher. Here it's narrow, 49 to 51. Right? But that doesn't mean that the sales are low. So is the x-axis telling us anything about the number of sales? Is it telling us anything about the number of sales? No. So the x-axis is not telling us about the number of sales. Y-axis is not telling us about the number of sales. So how can we say that as a group the sales were highest in 2011? We can't say that, right? We just know that how many people were comparing, how many people were making sales comparative to the median. But we can't tell no that they are making more sales or less sales. So the answer of 2 is C. Neither supports nor refutes. And this is, and even if you got this question wrong, absolutely no need to worry. It's a 95% hard question, like most people get it wrong. But a very, 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 very important concept to know here is this. Like, this is a very, very common trap. So if you are taking one thing out of this video, take this. Okay, just one thing. Just 1 second, Jaideep. I'll complete. Yes, correct, Aditi. The formula is just to throw us off. We don't really, and that is why it is data insights. There are two things in data insights. It's about what data to use and what data not to use. They are testing us on both these things. And the entire purpose of showing the formula was so that we could drive the inference that the 0, 1, 2, 3, 4 is not based on the number of sales. It's not that if you're doing 10 million, you are at 3. If you are doing like 1 million, you are at -1. The formula is to show that, listen, it is, thank you, and actually, the formula is just to show that, listen, this is based on comparison to the median. We don't know. It's not an absolute number. It's not an absolute value. Yeah, and that's what they do. That's what they try to throw us off. Oh, damn it. Yeah. And that's what we need to figure out. That's what we need to know, which data to use and which data not to use. Okay, I'm going to address Jaideep's doubt. Okay, Jaideep says the formula given can also be written as individual total is sigma into. Oh my God, okay. Okay, we know that individual ratings are not the highest, though this through this we can infer that mean would be less. Okay, so again, right, just because an individual rating is not the highest, let us say that in a class, okay, the individual rating, let me think of how to explain this well. You are saying that the individual ratings are not the highest in 2011. We can infer that mean would be less. Okay, let us say that the out of 50 million, okay, if the mean is 50 million and a company is performing at 10 million, sorry, an employee is performing at 10 million, that employee would get -3. But let us say if the company itself is performing 1 million and that employee is performing at, let us say, 900,000, that employee would be at a -1. So based on -3 and -1, we cannot know how much the company is performing, how many sales are happening. Does it make sense? The individual sales rating is basically comparing with the 50 billion or like the 1 million. But because we don't know these numbers, how can we infer what the plus minus of that is going to be? I hope this is clear to you, Jaideep. Okay. You're saying you got the first part wrong as you infer that total employees are not representative in the bar chart. Yes. And that is why it's important, right? So, first of all, thank you so much for pointing this out and thank you so much for getting this. That's why it's important that before we even go to this, we are looking at the chart. We are looking, what does the x axis say? So, I want you guys to do this thing. What does the x axis say? Second, what is the y-axis? My handwriting is so bad. But yeah, what is the y-axis saying? And you pick up a data point. Pick up one data point and just say, what does this data point mean? So if in this case, like people got wrong because they did not pick up a data point. But if you would have picked up a data point that, okay, you know what, this gray thing, okay, let us look at this. This blue thing over here means that, okay, these are the people who are probably doing near the mean, and there were 100 employees who were kind of scoring near, not scoring, but like kind of earning near the mean, right? Okay, I hope this was clear to you guys, and I hope that. Oh yes, I was. Yeah, this is a very common trap. So what they'll do is they'll like look at percentages, they'll give you numbers, they'll try to confuse you, but you have to be very clear in your head what the inference is, and if you do that, you'll not fall into the trap. All right. Now this again, like how much time it takes. Reading the text takes 20 seconds. Studying the chart 12 seconds. Reading the question takes around 10 seconds. Solving 5 seconds. Again, so this is like less than a minute. You can solve this question if you have drawn the inference correctly. Okay, and like 43% people only get this right. More than half of people get it wrong. So you have to own the data set. All right, now look at this one. And yeah, here you will need to do some extra effort, guys. Sorry. I'm going to share an Excel sheet link with you. You will need to open the Excel sheet for sorting purposes. And based on that, you'll need to solve this question. Rashmi, do you mind sharing the Excel link? You'll have to open it. The document is view only. You'll have to make a copy of that document and then you will need to sort it out. I'm going to give you guys more time because it's a bit logistical. Okay. Are you guys able to click on the link? I'm just assuming yes. If you are not, then just tell me. So I'm going to give you guys a little more time for this because, it'll be like a bit of a task opening Excel and all. But yeah, it's required. What can we do? As soon as you are done, come back here with your answers and give it in the format Y and Y, N and Y, all of that. Have you guys opened the Excel? Are you able to sort? Are you able to solve this question? Last 1 minute, please drop your answers on the chat. Awesome. Yes, yes, no. We got our first answer. Anybody else? Last 30 seconds. Great. We're getting a good variety of answers here. So we have YYY and YYN, the other two most common ones. Okay. Now let us look at this question. First of all, as per usual, NYY also. Okay, interesting. Now, as per usual, we will start with our data set. We'll see what it means. We'll draw inferences. And meanwhile, why, as I'm explaining it, what are the inferences you could draw from this data set? Drop it in the chat, okay, while I'm explaining. All right. So, a survey of workers' well being grouped respondents according to occupation. Okay, so one, three, four, all these are different types of occupations. And what is a survey? It's about the workers' well being. For each occupation, the table shows the percentages of respondents who indicated feeling satisfaction in their occupation. Okay, so this entire thing is showing how satisfied they are, being in a positive mood with respect to their occupation. Okay, this is about how much of a positive mood that they have at the time of survey and having a sense of purpose. This is about having a sense of purpose. Okay, so what this is saying. So again, as per our normal way of doing things, let us look at one particular data point. Okay, let us look at this one. So, like for occupation one, like 30% of them said they were satisfied, 76% of them said they had a positive mood, 39% of them said they had a purpose. Now, what is the inference to draw here? So, whenever you are getting percentages, what should you think of? What is the first thing that you need to think of? Is it adding up to 100, 30, 76, 39? Is it adding up to 100? No, right? It is not adding up to 100. So, what is the first and a very, very important inference to be drawn in this question? Because it is not adding up to 100, there is a possibility of an overlap. So, it is possible that, let us say, one worker said that they were satisfied, had a positive mood, had a purpose. It is possible that one worker said that they were satisfied and had a positive mood, but not purpose. Right. So this is the first inference that you draw here, that there can be some sort of overlap. Now let us go into the options. So this says yes and no about positive and negative correlation. So let us look here. It says that there's a positive correlation between percentage for satisfaction and purpose. Okay. So now let us look at table one. So when we are supposed to find, yeah, can we make an inference that a user answering yes to one does not mean necessarily mean yes to another, but it can. Fantastic. This is exactly the kind of thinking you need to have. Brilliant. Just because somebody is answering yes to one, it does not mean that it is yes to another, but it can. Perfect. All right. So now if we look here, like if we look, what were we comparing? Positive correlation between the percentage for wait, between the percentage for satisfaction and purpose. Okay. So when we are supposed to find, kind of like a correlation of sorts, or like determine if there is a correlation or not, we will just sort one table and we'll see what that does to another table. Okay. So here we sorted satisfaction from lowest to highest. Okay, so it's went from 0.3 to 0.76. Okay, sorry guys. What is happening? Uh, just give me a second. Where is my draw tool? Okay, draw. All right, great. Hmm. So, yeah, so satisfaction is going from zero point 0.3 to 0.76. Now, look at what is happening to purpose. So, when we are supposed to determine if there is a positive correlation or negative correlation or not, let us see that when I am sorting one group, right, from lowest to greatest, how is the other group sorted? This is the lowest and this is the greatest. Right. So this is also going from lowest to greatest. So that is our first inference that, okay, this could be a positive correlation. Now let's look here. Here they are increasing. Let us say here they're increasing, slight decrease, but one data point doesn't mean all that much. Again, increasing, they are the same. But what is the trend? The trend is that they are going together. As one is going from lower to higher, the other is also going from lower to higher. So we can say that yes, there is a positive correlation between the percentages of satisfaction and purpose. All right, now what is the second one? Second one is saying that there is a negative correlation between the percentages of positive mood and purpose. Okay, now let's have a look at it. So if we look at positive mode and if we try to sort it out, give me 1 second, guys. This is so hard to operate. Hmm. Yes. Okay, great. Yeah. So here is it, we also sorted this in ascending order. So it is going from lowest to greatest. Okay. So what am I supposed to find? Percentage for positive mood and purpose. Okay. So as the positive mood is increasing, what is happening to the purpose? It is decreasing. The purpose is the purpose started at 0.74, but it is decreasing to 0.44. Let me just show you with this. Hmm. The purpose, yeah, the purpose had started at 0.74, but then it is decreasing to 0.44. So what is happening in that case is that there is a kind of a negative correlation, right? Because as one is increasing, the other is decreasing. So if we look at it like from data point to data point, let us say that the first one is 0.74, then again it is 0.74, then it is decreasing to 0.55, then it is decreasing to 0.46, it is decreasing to 0.39. Just because in one data point it is increasing from 0.39 to 0.44, it does not mean that in the rest of the data points it is not negatively correlated. So we can say that yes, there is a negative correlation. So it is a yes and a yes. Now let us look at the third one. And again, I'm so sorry for the tech issues, guys. Hmm. Third one says that a majority of all respondents who indicated feeling satisfaction also indicated having a sense of purpose. So here, I think this is something which actually trips a lot of people up. And here let us figure out what this actually means. So if we look at it, who indicated feeling satisfaction? So let us look at point one, right? 30% indicated satisfaction and 39% indicated feeling a sense of purpose. Are they the same people? Are this 30% people and these 39% of people the same? Think about it, yes or no, or we don't know. The answer is we don't know. They could be the same people, right? They could be like some 30% people and 9% people here, or they could be completely different people. But we don't know. How can we make that inference? Again, here also 31, 44, they're different. 53, 55, they could be separate to 50% people, right? 55, 46, different. 76, 74, yeah, here there are chances that they could be like a same kind of similar people. Here also they could be the same people. But in majority of the cases, what is happening? That we don't know if they are the same people or not, right? So because of that, we can actually say that the majority of people who indicated feeling satisfaction also indicated having a sense of purpose. We cannot say that. Right, exactly. If it was both 100, we could have said yes, but we cannot say that. Right. So, whenever you are having percentages, and in percentage you are having an overlap, and there you are asked in question, do majority agree or not, the first thing that should pop into your mind is sets, sets. So we need to know, are they overlapping or not, or can we determine or not? Got it? So this is something, this is now that we have put it in this way, it becomes so easy, right? We cannot determine that they're the same people or they're different people. So how can we determine that majority of them who indicated feeling satisfied also indicate having a sense of purpose? But still, this is something that because we drew inferences from that data, because we drew the overlap inference, because we used overlapping sets to figure out like could they be different or same, because of that we could actually answer this question really easily. But this is like a very hard question. It is like a proper 700 plus question. So yeah. Okay. All right. So did you guys understand this question? Did you guys understand what we did? Because next question is going to be very, very complicated. And I'm warning you guys. It's very complicated. So if you understood, I'm going to move on. And actually, before we go to the next question, I want to ask you, like, up until now, are you enjoying the session so far? What have you learned? And again, I want you to tell me actionable insights. Like, what is something that you're going to take from the session and then you're going to apply to your DI practice, or like, in general GMAT practice. What have you learned so far? Let's have a mid-session check-in. Anything, however small it is, put that. What have you learned? I'm going to give you guys 30 more seconds. Does it mean that in majority of cases we can tell for two cases that the same people could overlap? Yeah, that is the thing, right? They could overlap or they couldn't. Right. Let us say, like, we have a total of, let us say there are total 30 third, no, like apples is a very wrong example. Let us say that, okay, let us say that however many, there's a total of 30 people. They could be either Indian or like they could be women, right? So they could be Indian women as well, right? So we don't know that, right? But they could, let us say like they could all be like 30 Indian women, or it could be 15 Indians and 15 women. We can't really know that. Hmm. To make sure what is asked is actually present within the data. Yes, exactly. Individual rates. Okay. I did not understand how we approach the last part of the question. Awesome. Be wary of traps. I'll show that again. How do we say top two may be similar and the rest are not? Okay. All right. Let us go back to this question. Okay. Let us go to top two. So, what does percentage mean? Percentage means that there is a total of 100. Okay. So, like out of a total of like 100 people, if 76 people are saying that they are satisfied, and if 74 people are saying that they have a sense of purpose, so how many, let us assume that they are completely intersecting. Okay. There are two ways. Okay. Out of the 76 and 74, okay, they are completely intersecting. So what does a complete intersect mean? It means that 74 are such which are like, purpose, and 76 is satisfaction. So basically this is purpose plus satisfaction, this is satisfaction, and this is the rest of them. No purpose nor satisfaction. So basically 100 minus 76, which is 24. So this is how it is if there is a complete overlap. Okay, let us say now, like now let's take the opposite scenario where there is like as little overlap as possible. So if we are looking at little overlap, so if we are looking at little overlap, so we need to make them as far apart as possible. So 74 and 76. But the problem is that 74 plus 76 is 150 and the total is 100. So 50, at least 50, they must overlap. So in either case, either between 50 to 74 people are overlapping. So at least 50 people are such who are both P and S. And that is the majority. Does this make sense? Priyanka, does this make sense? Because even in like the worst case scenario, because 50 people are overlapping, we can say that if we were asked that in occupation 2, a majority of respondents who indicated feeling satisfied also indicated having a sense of purpose, we would have said yes. Because what is majority? If we look at majority, the yeah, people like out of let us say 74, majority is basically what 74 by 2, which is 3, 6, 7, yeah, 37. More than 37 people did the majority feel or not. And even in the worst case where we are having the littlest overlap, there's still 50% over. There's still 50 people who are overlapping. Does it make sense? How did we approach this? Is it clear to you, all of you guys, Priyanka especially, to notice a subtle shift in the question stem? Yes, very good. But is this concept clear? How we approached overlap? We looked at both scenarios. Total has to be 100. So either there's a complete overlap, in which case 74 people are like P plus S, or as little as possible, in which case there's 50 in overlap. For example, yeah, very, very good, point. Yes, we are assuming that. If we are not assuming that, it's going to be mentioned. Yeah. Okay, perfect. Now take this principle in mind, and I'm so glad that you asked this question, Priyanka, because this is going to be very important in the next question that we do. Please, Rashmi, could you please put the link for the next question? It's going to be tricky. Awesome. It's going to be a little bit tricky, but I'm going to give you guys 3 minutes, solve this question, and tell me the answer. And use the method of overlap. As soon as you're done, start dropping your answers in the chat. Okay, Aditi, your answer is in. What about others? I'm gonna give you guys 45 seconds. Okay, last 10 seconds. Drop your answers. All right. So thank you so much, guys, for participating. Let us look at this question. Could you please explain the difference between the first question here and the second question in the previous table's question? Yes, we'll come to that. Don't worry. And actually, this the question that you asked, that is the main crux of why we even put this question here in the first place. Okay. Now let us look at this. First, what we'll do is we will understand, we will own the data set. So, a school district surveyed 100 parents to gather their opinions on the district's budgetary priorities. The table shows the percentages of all survey respondents who indicated that they strongly agreed, somewhat disagreed, or strongly disagreed that each of the four actions should occur. No other response options were available. No respondent could choose more than one response option for each action, and not every respondent gave an opinion for every activity. What does this mean? So I think somebody asked this question here earlier that, like, what if people did not select anything? So here it does say that not every respondent gave an opinion for every activity. So if we look at this activity here, reducing class sizes, there could be people who did not select anything here. So there could be a none column here, none column here. And I think like a lot of you have actually performed really well on this question. I'm really proud of you. So I'm pretty sure like this particular inference you guys would have drawn, that not every respondent gave opinion for every activity, which means that there's a none column here. Okay. What does this mean? No respondent could choose more than one response for each action. What inference can you draw from here? There is no overlap. In the last question we had seen that, oh, there was some sort of an overlap there, right? But here, because one respondent has chosen only one thing, there is no overlap. Okay, now this is what everyone has chosen. Great, Aditya. So here, if we look at it, like how will we calculate none? We know that, all of this, it should go to one. And like, in certain cases, this will not come to one, this will come to a certain number. So that is the people who have not answered. Okay. And we don't need to do that calculation here, but we just need to know what this means. So now let us look at this. From each of the following questions, select can be determined. If the answer can be determined, otherwise select cannot be determined. Okay. And in this first, let's start this. Did most respondents who indicated that they somewhat agreed that class sizes should be reduced? So when you read this, right, the first thing is that most respondents who indicated that they somewhat agreed that class sizes should be reduced. What are they talking about? Look into the table. Somewhat agreed that class size should be reduced. They're talking about this number. Got it? This is the first inference to draw in this option. Okay, like we have to locate with whatever everything's saying, we have to locate where it is in the table given. Also indicate that they somewhat agreed that music classes should be added. Okay, so somewhat agreed adding music classes. So here, so these are the two things that we are comparing. Okay, now when you say most, what does most mean to you? What is most? What should come to your mind wherever you read most, be it CR, be it RC, be it DI, be it quant? When you read the word most, what should come into your head? I'm going to wait for answers on this. There's a bit of a lag on YouTube, so more than half, okay, more than half, more than 50%, very good. Most means more than 50%. So whenever you are seeing most, the first thing you need to do is you need to be like, okay, more than 50%. And if there is a number given to you, you need to calculate that. Most is something that GMAT loves to pick on a lot. Most, must, only. It loves all these modifier words. So, if we look here, did most respondents indicate that they somewhat agreed? So, most of this. So, most of 0.47. So, what is greater than 50% of 47? 24? Hmm? 50% of 47 is what? 23.5. And since we cannot have half a person, it is 24. So, did 24 people, somewhat agreed should be reduced, also indicate that they somewhat agreed that music classes should be added? So, how many people think that music classes should be added? 22. Why? Because this is what we were comparing, 22. So, 22 people think that music classes should be added. So now, if we are rephrasing the question in our own words, what is the question asking? Question is asking, did these 24 people, are these 24 people and these 22 people, like, are they the same? Essentially, that is what the question is asking, right? So now, if we look at it, now we are going back to our overlaps. Okay, let me just clean this up a little bit more. Array. Okay. Now, when we are going into our overlaps. So, as usual, we will do our max overlap, then we will do our min overlap. Okay? So, in max overlap, what is happening? That there are 24 people who are like the max here, and this is 22 people. Are they are they all the same? They are not, right? There are still two people. There are two people who are into reducing class sizes but not into adding music classes in max overlap. Does this make sense? That 24 people, let us say most of those 24 people, they are wanting to reduce class sizes. Most of, and 22 people, they want to add music classes. So there are still two people who don't want to add music classes. And because this 22 number is lesser than the 24 number, even in the case of maximum overlap, we can say that the answer is no. The most respondents who indicated that somewhat class size should be reduced don't indicate that they agree that music classes should be added. Because the number of people who agreed that music classes should be added is 22. But most respondents, they are 24. For them to also indicate that both of them, this number of music classes, it has to be 24 or more. Does it make sense? It's a little bit tricky to understand. This is like a very complicated thing. But does it make sense? When I'm saying most in reducing classes, it is 24. This is 22. So there is, even in the case of max overlap, there are still two people who do not want to add music classes. Perfect. Now, if we talk about min, so this could be separate 24 people, this could be separate 22 people. Nobody wants music classes to be added. So, what does this tell you? That in both the max scenarios and the min scenarios, most people do not want music classes. They don't want music classes. If this number was, let us say, 25, right? Instead of 0.22, it was 0.25. Then we could have, probably, then it would not have, then it would have been cannot be determined. But because of the sheer fact that this is 22, it can be determined. That's why this is a yes. Let me just clear this out. That's why this is a yes. Because it is in no way, it is not possible in either max or min that this statement is true because the number is 22. All right, now let me look at the doubts. I think I'm confused for in this scenario of how you know if the person voted for both as it is just percentage. Yeah, so that is what, right? Like if we are assuming in most 47, this is 24, right? We don't know if it is the same person or not. We don't know if these 24 and these 22 could be the same. That's why we are taking two scenarios. We are taking two scenarios in which 22 of the people are the same. So these 22 people are the ones who voted for both reducing class sizes and adding music classes. But even in that case, there are still two people who voted for reducing class sizes and not music classes. That is the max scenario. What is the min scenario? Is that these 24 people and these 22 people are completely separate, completely different set of people. In which case, obviously, they will not vote for, they're different people, right? So we have to figure out are they the same or not, and they are not. They cannot be. It's mathematically not possible for them to be the same. Is it? Does it make sense now? I'm not able to pronounce your name, but does it make sense? So we don't know if they're the same or not, but since 24 is more than 22, even if they're same or not, it does not matter as the numbers don't match. Correct. So would answer still be cannot be considered even if it was 24? No. If it was 24, it would be cannot be determined because they could be the exact same people. Then it would be like most respondents who indicated would also indicate that, right? Because they're both 24. They could be the same set of 24 people. We don't know that. It could be even if it is just 0.22, it was if it was 0.25, if it was 0.26, then the answer would have been cannot determine. But because it is 0.22, the answer is can be determined. Because we did the math, right? That it is not possible for them to be the same people. Aditi says, so we do not know if they're the same or not. Yeah, makes sense, right? Like we are supposed to find, like, how many people uh, like apples or blueberries, right? And we know that five people. Aha, yes. Okay, let me make it simpler for you guys. Okay, if I am saying that everyone who likes apples likes blueberries, okay, and if let us say there is five people who like blueberries and there are seven people who like apples, so what's going to happen? Can this statement be true that everyone who likes apples like blueberries? If there are seven people who likes apples and five people who likes blueberries, can this statement be true that everyone who likes apples likes blueberries? No, right? Because even if let us say let us say that they are the exact same, like everybody who likes blueberries likes apples. Let us just assume that everybody who likes blueberries likes apples. So there's five people here. There's zero in the blueberry. There is still going to be two people who like apples but they don't like blueberries because we are limited by the number of blueberries. I hope this makes it more clear. Okay, now if you have any doubts, please post it. This is again, it's a complicated question, but just think about it like that, right? What can you infer from numbers? If they are saying most, if they are giving numbers, they want you to calculate. So does exactly half count as most? No, it has to be more than 50%. In our case, it was 23.5. So 24 counts as most. In case of more than one scenario, if the question gives option of cannot be determined, won't it be the default choice even if there's a possibility of more than 24 people common in both groups? Okay. Let us look at that. Okay, let me give a scenario. So everyone who likes apples likes blueberries. No, let's not do this. Let's go back to this question, right? In this question, if we were looking at 2 and 4, what was happening? That they could be the same people, they could be different people, the majority of them were the same. If you were looking at 136, what was happening? If you look at 30%, 39%, they could be a completely different set of 30 people who have satisfaction and completely different set of 39 people who have purpose. Or it could be 39 people who have purpose, and out of those 39 people, 30 people have satisfaction. Does this make sense? We don't know that. They could be either separate people or they could be all the same people who have purpose, and out of that 30 people have satisfaction. So that is why, like, when you are given a question like this, you need to basically figure out what is the max scenario that's possible, what is the min scenario that is possible. And this question, like, involved is, we had to do two things here, both the max and the min, and second is the most part, which is like, figuring out 24 as a number, which is why it's a complicated question. But I hope that you guys understood why exactly it is can be determined. If you have any other doubts, please post it. If you understood this, especially to those who understood it, put it on the chat. What did you understand? Like, what did you get out of this question? And again, sets is something which, like, advanced topics comes in quant, trips a lot of people up, tripped me up when I was studying. So yeah, it is something which is hard. But like, it is something which is very directly relevant in DI. If you learned anything from this question, if you want to, give a one line thing of, what to do in this question, put it. It is a very tricky one, not just a tricky one. This is one of the hardest ones. I don't have the metrics, but it's like I had it somewhere. It is very hard. But you understood the core thing, right? Like, if we think about the apple and blueberry example, we know for a fact that this is false. It can be, the answer of this can be determined. No matter what, the answer of this is going to be a no. It's a very, yeah, a lot of people make this mistake. One of the most common mistakes that's made in this. It's not a yes, no, it can be determined, cannot be determined. That is why it's very important to read this question stem as well. Okay, great. Now, let us move on. How much time do we have? We have some time. We can move on to the last question. I hope you guys are enjoying the session so far. If you learned anything out of it, please press the like button. Okay, I'm a YouTuber now. All right, now let us do this question. Multiple, okay, for the previous question, multiple responses are allowed here. That's when the previous one it is a no. Yeah. Great. Now solve this question. You have 3 minutes. It compared to the others, it is easier. So I think I'm expecting a lot of you to give the right answer here. Table 3. What about the other questions? Oh, right. Sorry, my bad. Sorry. All of you got it right, so I did not move it to it. Sorry. Yeah. So it said that what percentage of all respondents chose not to give an opinion about they could be improved. We had a none table here, right? Remember, we talked about the none table. So based on the none table, we can figure out. Yes, yes, guys. Wait, yeah, I got it, guys. Sorry, my bad. Yeah. So second question says what percentage chose not to give an opinion. So we had a none table, right? So none table are basically one minus whatever the sum of this entire thing is. Let me just clear it out. Right? So based on the none table, we know we can calculate what is in the none table, right? So improving athletic facilities, it'll be like, whatever the sum of this is, 1 minus s. That is the number of people who did not reply, right? So this is something which we can determine. Now, if we talk about the last one, what percentage of all respondents indicated that they strongly disagreed with all 4 actions? So here, this is like 2%, this is 17%, this is 20%, this is 35%, but we don't know if all of them fall under this 35% bucket. Like, let us say that um, yeah, let us say that, like, 35% strongly disagree with them. And those same people strongly disagree with this and this and this. Or it is completely different set of people. 35% people, they disagree with improving facilities. There are separate 20 people who disagree with expanding library hours. There are separate 17 people who disagree with adding music classes. So we don't know that, right? So that cannot be determined. We don't know if they are all the same or they are all different. So that is being done in sets. That's what we need to figure out. Are they the same or different? Can that actually be figured out or not? Hmm. Is this clear? I think we got guys got such a difficult thing correct. This should be easy for you. Is this clear to you guys? Can we move on to the next one? Do you guys have any questions? Okay. If you have any questions, let me know. I am moving on to the next one. So the final answer is can be determined, and cannot be determined. Okay. And just whenever you're confused, think of this. Whoever likes, everyone who likes apples likes blueberries. Seven people like apple, five people like blueberries. We can definitely determine that this statement is false, even if everybody who likes blueberries likes apples, because there's always going to be these two people who like apples and not blueberries, even with a complete overlap. Again, this could be very separate people also. Seven people, separate people like apples, five people, separate people like blueberries, 12 people. Yeah. Okay, do this one now. You guys have 3 minutes. Exactly. Very good, Priyanka. Very nicely put. You can determine the horizontal calculation, but not the vertical. Correct. Rashmi, can you please put the table three? We will give you 3 minutes and then we will move on to this. If you've come up with the answer, please put it on the chat. Come on, guys, a little bit more quickly. Last 60 seconds. Okay. Most of you have gotten it correct. Very good. Proud of you guys. Okay. All right. Now let's look at this question. So, first, as usual, we will try to completely own the data set. So, this says that with reference to this table, a statistician has proposed the following criteria for determining the most geographically typical of the listed Australian something that's been cut. So, but what is happening is that we have the different states, and then we have, different like a land area, population, density, percentage of populations. These are the four different parameters. Okay, and based on that, we have to find out if they are typical or non-typical. Okay. Now it says for each of the four categories of statistics, a state or territory is typical if and only if it is neither among the 25% of territories with the least values nor among the 25% of the territories with the greatest values. Okay. So basically, somewhere in the middle. Now, when you look at 25%, what is the inference that you draw? How many states are there? There are 8 states. So, what is 25%? Top 25% is what? Top two states. Bottom with the least value means bottom 25% is what? That is the bottom two. So, the way that we need to approach this here is that we need to sort each of these tables and we need to figure out which of them are in the middle four, right? Which is not in the top two, nor in the bottom two. Okay. Uh, just give me 1 minute. I cannot pronounce. I'm so sorry. I cannot pronounce your name. Give me 1 second. Let me. I'll come to that. Don't worry. Okay. So if we look at sorting it, okay. All right. Okay, so if we look at sorting it, so if we look at, let us sort based on land area. Why is it not sorting? Give me a second, guys. Mm. Okay, you know what? I'll just present it here. Hold on. Okay, is it visible? All right. So if I just try to sort it here, if I sort land area, okay. So what is top two? Australian territory. Is my screen visible, guys? Yes, no. Okay. So, what are my top two? My top two are Australia and Tasmania. What are my bottom two? Queensland and Western Australia. So, my middle four, they are the typical ones. So, let us do this. let us be like Victoria. What are the middle four? Let us look at the states and how many times are they typical, okay, in each sorting. So if we look at area sorting, all right, what are the typical ones? Not these two, not these two. So we have Victoria, we have New South Wales, we have South Australia, and we have Northern Territory. Okay, so these are the ones based on area. So it's like, one, 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 one. Okay, now if we are sorting based on the population, so we are not supposed to take these two, Northern Territory, Australian capital. We're not supposed to take the bottom two, Victoria, New South Wales. So these four, these middle four ones are the typical ones. So we have Tasmania, we're going to put T here, Tasmania is one. We have South Australia. Okay, we already had South Australia before, so this becomes two. We have Western Australia. Western Australia is not there, it's a new one. So Western Australia is one. And then we have Queensland. Queensland also new one. So what we are doing is, because the entire question is about finding out the typicality, we are just having a look that, okay, what are the typical and the non-typical ones? Okay, here, not the top two, not the bottom two. South Australia again, so that's a 3. Queensland again, so that's a 2. Tasmania again, so that is a 2. And New South Wales again, so that is a 2. Okay, now we'll go to percentage of population. Tasmania, Queensland on the top, South Australia, ACT at the bottom. So which are the four here? Can you guys see my screen? Yes, fantastic. Okay, so which are the four ones here? Northern Territory. So Northern Territory gains one more point. That's a 2. New South Wales is a 3. Victoria is okay. Victoria is here. It's a 2, and Western Australia is a 2. Okay, so this is the major thing that we have gotten, and this, with this in mind, if now we then evaluate the data set, it is going to be much, much, much easier to do that. Okay, now let me just share my iPad screen. Give me a second. I don't know why my iPad is glitching today. Okay. All right. All right. Now, let's get back here. What is happening? So here, let's just clear the markings. So what had we inferred? I'm just going to quickly write it down here. We had inferred that Victoria was a 2, NSW was a 3, SA was a 3, NT was a 2, Tasmania was a 2, Western Australia was a 2, and Queensland was a 2. So how many are these? There are 7 of these, right? What is missing? There's only one which is missing. Which one is missing? Australian Capital Territory. That is the only one that is not typical. So Australian, that is a 0. Okay. Now keeping this in mind, let's evaluate. New South Wales is typical in more categories than any other listed state or territory. Okay, so what does it mean? More than any other. And actually, this is a very basic thing, but this is something that trips up a lot of people, which is why I have, included this. If let us say, this one is also a 3 and NSW is a 3, is it more than any other categories? Or is it equal to? What does this say? It says more than, and more than equal to. Again, this is a very small thing. But if you look at OG, like these types of questions, they'll come up again and again and again. And these are the basic things that they will test you on. So this is a no, it is not typical in more categories than any other listed state or territory. I hope this is clear to you guys. Now, let us look at this one. No listed state or territory is more typical than South Australia. Let's go back here. South Australia is 3. Now, what does this statement say? It says that no territory is more typical. So when it says that no territory is more typical, and how many does South Australia have? 3. So it says that no territory has 4. Right? That is what it says. Do you get the difference? Can you appreciate the difference between statement 1 and statement 2? They seem very, very similar. But when we are actually putting in mathematical terms, we are able to figure it out. So statement 2 is saying that no territory is more typical. And this South Australia already has 3. So basically what statement this is saying is that no territory has 4. Does any territory have 4? No, it doesn't. So this is correct. Now let us look at the last one. The ACT is not typical in any of the categories. We have already determined that not in any of the categories. So here what did we do? Because we did the typicality analysis before, because we made this data set for ourselves, it literally took us seconds to come up with this answer without any confusion at all whatsoever. But if we would not have done that, it would have been very difficult for us, right? So that is why it is really really important to own the data set. And I don't know how many people made mistakes in the first and the second one, like getting confused between, like, very similar language. But if you did, then just be very, very clear what to do in the future, what not to do in the future. Whenever you are confused, so this is like a golden rule that I used to follow. Whenever you are confused, put it in numbers. What would it mean in numbers? That is actually what visualization is, and that would make life a lot easier. So great. So because of this, we could solve this question. Are there any doubts? Okay. Oh yeah, there was one doubt here. If it says typical in more than any other for one, does it mean it can be the only one with that amount and rest is less? I hope this confusion is clear now. More than any other, it means that if any category has something, it has to be more than that. Equal doesn't count. More than is not equal to. More than means only one. Okay, if there are no other doubts, then we can officially conclude this session. Are there any doubts, guys? Okay. How do I stop sharing? Okay. So, what did you guys learn? First of all, thank you so much. You guys participated so well. You answered everything. You asked your doubts. You were very, very active. It was a pleasure, doing this exercise with you. Thank you so much for that. And I want to ask you, what did you guys learn? We solved multiple questions. Let me just take you through what we did. We looked at different things across graphs, across tables. We looked at it in a decision making chart. How do we figure it out? What does must mean? Then we looked at, like, how to visually identify information in a table, looking at the x-axis, the y-axis, looking at one data point, what that data point means before even starting with the questions. And we went on to tables, we went on to positive, negative correlation. We looked at overlapping sets, when it overlaps, when it doesn't overlap, what it means, what does most mean. Okay. So Priyanka asks, since most of DI question type asks to each subpart correctly, how to avoid getting stuck into the problem. All right. So this used to be a very big problem with me when I was doing my very good, Isabella. Min and Max case. Fantastic. Yeah, so like, this used to be like a big problem for me. There was a time, I think, in mocks I had spent 7 minutes on one TPA question, and like it used to be such a big time sink. So I think when I started doing the mocks, it was important for me to identify that, okay, these are my major time sinks. So I gave myself a hard limit that, okay, listen, if I'm not close to finding an answer in 2 minutes, then I'll need to like guess and move on. But by actually using this approach of owning the data set, it makes it really easy, because because we front loaded that time into owning the data set, we could then solve the options really quickly, that we did not have to go into synthesizing the data again and again and again for each option. That is why this approach is really really important. Is there a schedule for when this channel does lives on YouTube? um I don't know like about other people's lives, but yeah, normally there's a schedule for my live sessions. We have it usually on Tuesdays. This time it was a Wednesday. We have, I think, two more sessions left. If I'm not mistaken, I think one or two more sessions left in the DI series. We have already done two sessions, one on MSR and one on TPA. They're very very useful, so you can just go and check it out if you want. If you have any questions, let me know. Tell me what you learned, and if you want to share any insights in this session or compliment me, please. The floor is yours. I'm just kidding. Oh. Any other questions, guys? So, if there's one thing that I do want you to take away from this session, it is that whenever you're looking at any particular, let us say separately for graphs and tables, whenever you're looking at any particular graph, before going into the questions, pick up a data point and explain it to yourself what it means to you. So then when you will look at it, you will figure out, okay, is this something that the graph is actually telling me or not? In table, especially in these percentage kind of things, it is very important to actually see what happens when they are all overlapping, what happens when they're not overlapping. When it says X percentage, what does it actually mean? Great. I think we are done for today. Does practicing DI from OG suffice? See, it is not about where you do it from. So the way that I'd like to look at it is first you need to build the concepts. So you cannot start DI until your verbal and quant are solid because as you saw here, if you do not know sets, no matter how good you know tables, you will not have been able to answer this question, right? So DI borrows from verbal and quant, so that needs to be perfect. Then you need to do concept videos or kind of concept learnings of how to approach question types. Then go for untimed accuracy metrics. Try to get accuracy metrics of 80% on medium and 60% on hard. Untimed, don't focus on time at that point of time. Then do timed sets, then mocks. So if you are able to do it all with OG questions, that is perfect. If you're not, then there are other questions that are available as well. But the major thing is not the number of questions you do, it is how you're doing them. Concept, untimed, hit those accuracy metrics. If you have not hit them, don't move on. Hit them. After that, do semantic time practice and then go for mocks. So that, when you have your first mock, you know, you kind of knock it out of the park. My first mock, I got 735. I'd not taken, I just taken the first draw mock, and then the first mock after prep was like 735, because I had made sure that if I did not get my untimed accuracy, I used to sit on. I remember sitting on a question for like more than 30 minutes. If I just needed to hit my accuracy numbers, untimed accuracy numbers before I actually moved on. Abhishek said got 655, aiming for 715. How many months do I need to put in? Again, it is not about the number of months. If let us, in certain cases, it's very imbalanced. Like, let's say your CR is amazing, beautiful, 90 percentile, but your RC is let's say 50 percentile. Then just working on RC is going to just prop up your score. Or let us say, that your arithmetic is really good, but algebra is not good. Or let's say your advanced topics are not good when the rest is good. So it depends on the targeted work that you need to do. There's no a blanket thing of time, but essentially the point is you need to do targeted work. Interesting session. Awesome. Thank you so much, Priyanka. Great. Are there any other questions for me? You guys are you guys have been a lovely, lovely, lovely students. Very, nicely answering questions. I'm glad. Okay. All right then. Thank you so much, guys. Have a great night. Very, very important practice. Right now, you have the concepts fresh in your head, what to do. The only way to make this not a Netflix scenario session is to actually go ahead, practice DI questions and see, oh, where is most coming up? Where is percentages coming up? Where do I need to look at the graph? Practice, 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 practice. So you will cement whatever you have learned. And yeah, once you do that, I think you should be golden. If you have any doubts at all, even if you're rewatching the video, anything at all, any doubts, put it in the comments. I'm going to address that right away. Great. All right. Thank you so much. Good night and happy learning.